the very large and much more demanding Convegno, so the big conference in August that is organized jointly by the Italian Society for the History of Science, the Department of Philosophy and Communication Studies at the University of Bologna, CEST, the Center for the History of Universities and the History of Science within the department, and also the European Society for the History of Science. So as some of you already know, that conference had to be moved to a virtual space because we are not going to be able to run it in person as we had hoped. So there was this idea of having a few sessions just before the conference at the end of August to warm up to it, and also to kind of test the system, see how this is done, and also kind of break the boundaries of our personal spaces and reach out to people that are not near Bologna or near Italy. So I'm very glad this is happening, and I'll just tell you a little bit about the format today. First of all, though, I want to say this time the talk is going to be recorded, and a version of this is going to be placed on a YouTube channel that the Society has. So you will have a chance to go back to it if you want to, or kind of tell people about it. So if you're not happy with the idea of being recorded, or you're shy, you can, first of all, if you don't have the screen, your video on, you're not going to be seen. Also, I'm happy to read your questions to Ilaria, and then she will answer your questions. So if you want to ask a question and you don't want to be the one opening up your microphone, you just put an X in front of the question so that I know that it's my job to read the question to Ilaria. Otherwise, you can signal the question with a Q, and then I will call your name, and you can unmute your microphone and ask your question. Now, this is the issue of privacy that I wanted to, or privacy that I wanted to mention. I will also write it in the chat so that it's there for everybody to read. Now, I invite all of you to unmute the microphones. I think that there is some experience among us. You all have your microphones more or less muted, but it's good to avoid having background noise during the talk in case there is any. I'd like to also say that I'm very thankful to the Italian Society for the History of Science for taking this opportunity to have these seminars, because we may kind of use these virtual environments again in the future. So today I have the great pleasure of meeting, not in person, unfortunately, but in a virtual space, Bruno BELHOSTE, who's Professor Emeritus at the University of Paris 1, or Paris 1. My French is not very good, but I think I kind of coped okay. With nearly 80 articles. I was so impressed looking at his CV. It was just kind of kept going on. 80 articles and essays, but also 7 edited volumes and 5 monographs. It's a very impressive publication record. It's clearly the leading authority in the history of science in France, working roughly between the period between the Enlightenment and the First World War. He has worked extensively in the field of mathematics and particularly engineering. He started his academic career working on a biography of Cauchy that came out, that was the labor of his PhD, came out in 1991. And it was published in English as well. And then that kind of led to more work on the history of the École Polytechnique from 1794 to 1870. And for those who know Paris, the location of the école is very close to where Bruno BELHOSTE used to work, and still probably spends a lot of his time around the Latin Quarter. So it's a great place. It's a great shame that they moved it far away because now the location of the école is not there anymore. And he's also been the head of the Institut d'Histoire Moderne et Contemporaine. So he's used to historians of all kinds, not just historians of science. So I would like to just mention briefly the last book that was published in French in 2011, Paris Savant, that then was recently translated, very recently. I'm really glad that this gives us the opportunity also to for those of us who teach often students with not a second language and sometimes only English, 2019 edition with Oxford University Press, Paris Savant, capital of science in the age of the Enlightenment. So I'm really glad, because we need materials for teaching this period. And now, and I'm really intrigued about this, even if it's not so close to the theme of today's talk, he's working on mesmerism. He's writing a biography of this wonderful and fascinating man, Franz Anton Mesmer, that I always talk about in my first year classes, because it always attracts the interest of the students. They're very fascinated by the story. And there are some beautiful images as well of kind of vignettes and satire about Mesmer. So it's a really good teaching material. So I will leave the floor to Professor Bruno BELHOSTE, who will introduce Ilaria AMPOLLINI, and Ilaria will present the paper, and after that Professor BELHOSTE will make a short comment about the gist of the paper, after which we will open the floor to everybody else for questions. Thank you. So now it's
microphone.
Okay, yes.
Yeah.
Can you hear me now?
Yes.
Can you hear me? Yes. Okay. Thank you, Monica, for a very nice presentation. So it's a pleasure to be here. It's a pleasure to discover Ilaria. It's the first time we meet, not through the internet. So I never used this kind of device, so maybe I will make some mistake. It seems to work very well, so I'm relatively confident. So I have the pleasure to introduce our speaker, Ilaria AMPOLLINI, who will speak about the diffusion, the reception, and the editions of the Récréations Mathématiques of the French mathematician Jacques Ozanam. So Ilaria is a postdoc researcher at the University of Trento, where she participates to a project dedicated to the communication of scientific research. And she published, that's most important, she published last year a very important monograph about the panic which raised in France in 1773 after Lalande calculated the probability of a collision, of a catastrophe, a collision of a comet with the Earth. And I think with COVID-19, risk communication has become a very hot topic. And it's very interesting to see how history can help to figure out the difficult problems of science communication in such a context. So it's with a great pleasure that I give the floor to Ilaria. So Ilaria, it's up to you.
Thank you really much, Professor BELHOSTE, for presenting me. And before I start, I also want to thank Professor Fontanari, who is listening to us. I saw him among the participants, because it is thanks to him that I have started to study the history of math communication. Professor Fontanari is professor of algebraic geometry at University of Trento. And I also want to take the occasion to inform you that at University of Trento, Professor Fontanari, together with Professor Achille Varzi and Paolo Giacomoni and Marco Andreatta, have founded this new laboratory that will work on communication, philosophy, and history of mathematics. So it's the right occasion to tell you about this new project at my university. So let's start now with the presentation. And can you see it now?
Yes.
Yes.
Yes. Perfect.
Okay, because I don't see you. So if you nod, I don't see you, your face moving. So okay. So today I'm gonna speak about the Récreations Mathématiques by Jacques Ozanam. And the idea of talking about recreational mathematics and one among the many collection of games, riddles, and riddles and puzzles and problems of math and mathematical matter is part of a wider project that I have, which is the project to study the communication of science and particularly math during the early modern age, during the more early modern period. And I come back to this in the conclusion. But anyway, Jacques Ozanam will be one of the last authors because his Récréations Mathématiques were published at the end of the 17th century. Can I ask you to unmute all the microphone, because I can listen, I can hear my voice just like coming back. Okay, so introduction, a pinch of historiography first, of course. I wanna cite these three authors, Heffer and Wardorf and Singmaster, among the many authors who in the last 30 years have been dealing with the theme of mathematical recreation, because they all have a point of view about the use and the importance of mathematical recreational mathematics collection that helped me in starting with my talk. So first, what are recreational mathematics collection? They are basically volume where problems and puzzles and enigmas of mathematical argument are collected all together, and together with other problems of physics and other disciplines, depending on the time when they are published. According to Wardorf, we cannot consider this type of collection as a form of science communication, at least until and at least before the 19th century. So in his book published by the Princeton University Press, he states that this type of collection, he goes along 500 years of history, became a tool for communicating mathematics only during the 19th century. I disagree with this interpretation, and I rather totally agree with Heffer and Singmaster point of view. These two authors have talked about recreational mathematics as a form of popular science. But the point is, why are they a form of popular science? Also, I don't really like the term popular science, I prefer speaking of science communication. In Italian, I would say divulgazione, but let's use the term science communication because I feel it as more neutral than popular science or popularization, because I think they are two terms that assumes there is a precise border, a precise line between the popular and the high knowledge, as you already know, of course. So the point is that I am willing to consider recreational mathematics collection as a form of math communication or science communication more in general. But we have to ask ourselves what are the elements that allow us to say that, and what are the elements we should be looking at, and also more in general, the question here is where is the demarcation line between a game which is just a game, like card games or board games, and a game used to communicate a form of scientific knowledge. So the story or the history of recreational mathematics is a very long one. As Sigmaster put it, mathematical problems are as old as mathematics, because mathematics is based on problems. So we can find mathematical problems already in the Egyptian tradition, the Greek one, the Chinese culture, and so on. But it's only in the early modern age that this collection specifically dedicated to collect mathematical problem started to circulate. And the very first one is the one you can see at your left, and it is the work by Luca Pacioli, the Italian mathematician, called De Viribus Quantitatis. Despite the title in Latin, the work was written in vernacular, in Italian vernacular. It never got published, at least until 10 years ago. But it is a collection of mathematical problems, and most of them are taken from the ancient tradition. Also, the translation of the Arithmetica by Diophantus gave a great impulse to the interest for the mathematical problems, because there were many in Diophantus' work. You see here two other examples, and probably the Bachet one is the most famous, because it is that the printed work that gave rise to a series of many other titles, particularly in France, but that they got translated in English or in German, not in Italian, from what I know today. And his Problèmes plus are very famous and are like a model for all the other authors that have been publishing the mathematical problems after him. So I'm focusing today on Jacques Ozanam because his figure is almost completely neglected, but it is an important one, and namely, he's important for me and for my studies because he has been dedicating a lot himself to the dissemination of mathematical knowledge. What we know about his life, we do know it from the eloge that Fontenelle wrote for the Histoire de l'Académie Royale, for the memoir de l'Académie de Sciences, of Académie des Sciences, and we know that he was born in 1640 in the arrondissement of Bourg-en-Bresse, like Lalande. And he was the youngest among his brothers, so his father had planned for him a career as a priest or in an ecclesiastical one, but then he met mathematics. As Fontenelle puts it here, enfin, il a vu par malheur des livres de mathématiques qui lui avaient appris à quoi il était destiné. So he just could not resist to mathematics, and he dedicated his whole life to it. He became a professor of mathematics first in Lyon and then in Paris. And we have these two works which were published before the Récréations Mathématiques et Physiques. The first one is the Dictionnaire Mathématique, published in 1691, and the second one is the Cours de Mathématiques, published in 1693. Both these works really well testify the sensitivity of Jacques Ozanam for the dissemination of mathematical knowledge, his awareness about the tools and the language that one should use to disseminate it to a wider public than the public of men of science or literates. And as you can read here, in the dictionnaire, already in the frontispiece, it says dans lequel sont contenus les termes de cette science, avec des raisonnements qui conduisent peu à peu l'esprit à une connaissance universelle de mathématiques. One may argue that Ozanam says that in the frontispiece, and it is not his choice, but maybe the editors and the printers' choice, but actually the concept is repeated several times also in the preface. So the idea of Ozanam is to drive his reader through the learning of mathematics peu à peu, so step by step. And a similar concept we find in the Cours de Mathématiques, where it says already in the frontispiece, toutes les parties de cette science les plus utiles et les plus nécessaires à un homme de guerre et à tout ce qui se veut perfectionner dans les mathématiques. So here in the frontispiece, we have the declaration about the audiences he intends to address to. And the important thing is here that he is thinking about the military class, which is the perfect audience for this type of popular, let's say popular, just to go faster, popular works in the early modern age, like it happened in Italy. For instance, we had a lot of vernacular works written in Italian dedicated to the military class. But also to everyone who wants just to improve his knowledge in mathematics. So a public which is an heterogeneous public, and a public who that is interested in mathematics not just for a reason of utility, but also for amusement or personal desire of knowing. And here we have the Récréation. I'm sorry, the date is wrong because I did manage only to find this frontispiece, this edition online, the 1696 edition, but actually the fourth edition was published in 1694. And so the point is that Ozanam, Récréations Mathématiques et Physiques testify his interest in disseminating the mathematical knowledge to as many as people as possible. And also his awareness about what he is doing. and his attention for the language, for the structure of the work, and for the language he uses. And this is what I want to show you. So starting from the preface, Ozanam is justifying the fact that he's publishing a work that apparently is like a superficial work, and he says that actually the mathematical games are important, are useful, and he says les jeux d'esprit sont de toutes les saisons et de tous les âges. Ils instruisent les gens, ils divertissent les vieux, ils conviennent aux riches et ne sont pas au-dessous de la portée des pauvres, et aussi de deux sexes, de tous les deux sexes. So here we have his awareness and his intention to address to a broad public that includes young people that can learn something through these games, but also the old ones that can just have fun, to the rich and to the poor. Of course, here we have some topoi, like the thing of the two sexes, so women and men, but still it is an important concept that testifies as his intention and his aim. And also he says, ces divertissements ont encore l'avantage qu'on ne peut y commettre d'excès, car c'est un exercice de la raison dans la justesse de ce démarche. So these games, says Ozanam, are also useful as an exercise, as a practice of reason. And again, in the preface of the second volume, that has also problem in physical disciplines, Ozanam says, je veux par mes récréations mathématiques enseigner tout le monde à faire ces sorcelleries qui faisaient peur aux gens du conseil du Justinien, et par là je ferai plus qu'un savant homme. So here we have his declared intention to teach something through his récréation, teach something à tout le monde. So basically to everyone. This is like a sort of mathematics for all, mathematics for everyone. And here the reference to sorcellerie, so sorceries, is a reference linked to the Justinian Code that condemned and prohibited mathematicians, but in the sense of astrologers. Anyway, the point is that he wants to teach to everyone mathematics. And as you see in the frontispiece, the matters treated in the Récréations are arithmetic, geometry, optics, mnemonics, cosmography, mechanics, pyrotechnics, and physics. And so, of course, all the first ones, so with the exception of pyrotechnics and physics, all the other are to be considered part of mathematical knowledge. We have arithmetics and geometry, which are the wings, as Plato said, of mathematics, the two pure disciplines, and then the applied ones, so optics, mnemonics, cosmography, and mechanics. This is really important because, like, for instance, in Bachet, we do not find the applied mathematics, and but in Ozanam, yes, we do find them, as you see, and all the part of applied mathematics played a fundamental role in the early modern age in relation to the vulgarization of knowledge. I'm thinking particularly to the mechanical treatises like the one by Guido Baldo del Monte, the Meccanicorum Liber, translated into vernacular Italian by Filippo Pigafetta for a wider public. So the treatises of mechanics and mnemonics and optics are perfect and interesting examples of mathematical dissemination during the early modern age. Now let's have a look at the structure and contents. Well, as you see here, Ozanam has been reflecting on how organizing the matter of his work and also what things to be included and what not to be. Because he clearly says here, you see that he has not included the demonstration of the problems, but only the problems and then the solution and the rules to solve them, but not the demonstration, pour ne pas embarrasser l'esprit de ceux que je veux divertir par la lecture de plusieurs problèmes utiles et agréables. Again, here we have these two adjectives which are very important. The problems proposed by Ozanam are useful, and the term useful is a term that recurs several times in early modern age in order to justify the importance of applied mathematics, but they are also fun, curious. They are a tool of amusement, which bring us directly to the Sciences Amusantes of the French salon of the second half of the 18th century. As you see, the first problem is a very fun one. We have a blind nun, and the reader is challenged solve this fun problem where the nuns have visitors, have men visiting them during the night, and they basically rearrange themselves within the rooms of the convent in order to avoid but this I don't know the English name anyway, the non the head of the nuns surveillance. But the point is that this problem, this very fun and curious problem, is different from the other ones because from page 2, essentially, problems change and also the structure change because at first place we had the argument, the specific mathematical matter explained, like for instance here the arithmetical progression. So as you see, there's the part where Ozanam explains the matter and it gives the basic rules, and then it challenges the readers to solve some questions. And the questions are all very similar. They are usually set in the market or in the countryside, and you have men who drink wine or women selling eggs at the marketplace. They are basically all the same since Luca Pacioli's work, but of course they also change together together with the mathematical progression and development. Here you have again another example, the game of guessing a number. Here you have the general rule, and then you have the specific listed questions. As he says here in the section dedicated to mechanics, his intention is not to choose only useful problems, because the intent of the aim of the work is not only to give useful knowledge or useful skills, but also to amuse, to entertain the readers. Then Ozanam points out that for the mechanics part, he has chosen the problems the most useful and the most the funnest one, but also the easiest to understand and to do, to practice, to experiment. The last element we should be looking at is the language, absolutely the language. And in particular, if we want to focus on the arithmetical part, leaving behind the physical part, the physics, and the other part of the volume, is the use of algebraic notation. Because if you look at the cours de mathématiques and at the Récréations Mathématiques, we have a really meaningful difference. And if you only look at the Récréations Mathématiques, it's like Ozanam does not use the notation of algebra taken from Cartesian, Descartes. Of course, here the history of algebraic notation is a very long one, starting from the copies of Diophantus Arithmetica and going through the centuries until the Geometry by Descartes. But if you look at the Récréations Mathématiques, you have the impression that Ozanam does not use the algebraic notation, or that he uses it very little. But then, if you compare the Récréation with the cours de mathématiques, you see that you immediately see that it does use the notation, the algebraic notation. He uses it a lot and with all the sort of problems. So here the hypothesis is that my hypothesis is that Ozanam totally chose not to use algebraic notation, or not to use it too much within the Récréations Mathématiques, in order to make them more understandable to a public even more wider than the public addressed with his course. This is hypothesis must be discussed further, because Ozanam presents actually the Récréations Mathématiques as an appendix to the course. So if we state at his words, it seems that the public he addresses is the same, and then we cannot really explain this difference of language. But if we think to his words like a justification, just a way to justify the publication of Récréation, and that in reality he did not think of Récréation as an appendix to the course, then the discourse and the hypothesis works a little much better. So that's 5 minutes, and then I stop. I want to dedicate them to one of the last edition of the Ozanam Récréations Mathématiques. That was published in between 1775 and 1778 in Paris, by the same editor, the same editor's family that had published the Récréation, the fourth edition of Récréation by Ozanam, and that was edited by Jean-Étienne Monteclat. Why is this edition important and interesting? Because Jean-Étienne Monteclat is a famous mathematician, born in 1725, and author of the Histoire de Mathématiques. He dedicated himself to the history of mathematics, and here you see the second edition of his work, of his masterpiece, because it is the edition that Lalande edited and modified after Monteclat's death. And so what is important of his Récréation is that differently from the other editions of Ozanam's Récréations Mathématiques, here the preface changed. And it is written by Montucla himself, of course. And the thing I like is that here you still see that sensibility and that interest towards the dissemination of mathematical knowledge, exactly as we saw it in the Ozanam work. But you also see a development of this awareness coherently with the fact that we are at the end of the 18th century. So here there are many concepts that in Ozanam's work are like they were there, but they were not explicitly said by the author, like the fact that mathematics is the most difficult, the most complex one among the scientific disciplines, as Montucla says here, or again the fact that the problems are told as small particular stories because as Montucla puts it, if one would only say that we have a triangle and we have to divide it in 3, 4, 5 parts is one thing, but if one says that there's a father who dies and who lives to his sons a field, a triangular field, and he needs to divide it in 3 equal parts, then it's different and it's easier to disseminate the same knowledge, the same concept through different instruments and language. And also, what we can see by comparing these two editions is the evolution of the contents. The structure remains basically the same, even if, as you see, of course, Montucla does not start his work with the blind known, but with a very serious introduction to the general concept of arithmetics. And we have new, but we do have, of course, new mathematical instruments to be used and new concepts, like, for instance, the attention to probabilities that was not treated in Ozanam first edition. And this is an important point because Récréations Mathématiques, the recreational mathematical works, open up a window on mathematic culture and mathematical development through a work that is a collection, is only, but not only a collection of game. Last thing, the language. Of course, Montucla uses algebra, the algebraic notation, the symbolic algebra. Of course, sorry, I don't want to be misunderstood. Of course, Ozanam used algebra. The point is that for his Récréation, he used the rhetorical one, so the told one, and not the symbolic Cartesian one. And here you see that Montucla uses all the notation he needs to use. What does that mean? It means that he was addressing to a public that knew he would have understood this notation. And that means that during this century, this new mathematical language had been penetrating into the culture, the more general culture. So not everyone, but many people were able to understand it. And I come to the conclusions. So the first thing to me is that I totally agree with Heffer and Sinkmaster views, and many of the works, not all, but many of the works belonging to the genre of recreational mathematics should be considered as a form of math communication. The problem is that if we want to state this, we need to identify those elements and aspects that allow us to speak of science communication in early modern age. So not only with a reference to Ozanam, Récreations Mathématiques, but for instance to Bachet or to Pacioli work, and we have to ask ourselves if those collections too can be considered as a form of science communication. And here are the elements I think we should be looking at: authors, awareness and intentions, audiences he intends to reach and actually reached audiences, and the language used, but also the easiness with which we are willing to point out that the role played by the Récréations Mathématiques in the diffusion of mathematical knowledge. So I'm referring to the 17th and 16th century, leaving behind the 18th century, which is already well studied by scholars who are interested in the history of science communication, should prompt us to more widely investigate the theme of science math communication in the early modern age. We can discuss, of course, the use and the choice of the term to indicate it, but I'm thinking, for instance, the easiness with Emon, with which Emon talk about the books of secrets, like a form of knowledge for everyone, as Fioravanti put it in his preface, or all the studies about popular medicine or almanacs, and so on. So all these studies and also further references to the vulgarization and dissemination of knowledge in the early modern age should really prompt us to investigate the theme and to construct a history, a long-duration history of science communication. And the last point, which I would like to discuss with you, is that, as Sinkmaster put it, the problems are as old as mathematics, and there are many other independent fields, games and similar, that contain much recreational mathematics. So the question is, which ones can be considered, can be listed as a form of science math communication? Where do we put the line to distinguish between games which are just a game and games which have a role, a precise role, an intended and wished role, wanted role in the dissemination of mathematical knowledge? And here I come to the theme of the board games, which is the theme that I proposed for the conference in Bologna. And stop.
Okay. Thank you very much, Ilaria, for this wonderful paper. I have questions and comments, but I will now introduce again our commentator, Professor BELHOSTE, to make a brief comment on the paper. Thank you.
Okay, thank you, Ilaria. Thank you for your communication. Very interesting communication. I totally agree with you about the idea that it's not possible to make an a priori delimitation between something which would be mathematics and something which would be, I don't know, games. And I think we must have a much larger view of what mathematics was in the past, probably also what mathematics is today. But as an historian, we must have this large idea. So I totally agree with your your démarche. So let me give you, I will have only very few remarks about your talk, but my first remark is about math communication. It could be a good idea to use math communication as a category of not a category of actor, but a category of analysis. You to approach very different aspects of what was math communication in the past. And I will make some remarks about what you said about popularization. So I agree with you. I'm not comfortable also with the notion of popularization. And in my view, it could be useful to tackle this question in contextualizing it. So contextualizing can be a good approach because, you know, the notion of popularization, in fact, is linked to the development of what was called popular science in a very specific context. It was developed in the early 19th century in England, and popular science is the product of a new industrial democratic culture which emerged at this time, and which, of course, didn't exist in early modern time. So it's really related to a specific context with the development of popular press, of new urban shows, exhibitions, and so on and so forth. And it's interesting to see that in France, at the same time, was invented the notion of vulgarisation. Vulgarisation, which is in fact quite different from popularization, because in contrast with the English entrepreneurs who developed popular science, French vulgarisateurs were in fact servants of the savants, of the scientists. They wanted to adapt true science to a larger public, and they spread scientific knowledge produced by professional scientists. And so it's quite different. And when you consider now the diffusion of knowledge, the math communication, the science communication, if you use this word, in early modern time, it was quite different. It was quite different. And Ozanam's Récréations Mathématiques is a very interesting example, but we must keep in mind that it's a very specific example. There were many kinds of maths communication and many modalities, and recreations is only one modality among these different modalities. And I would add, Ozanam's recreation is it's also specific in this genre of recreation. So it's my second remark, it's about Ozanam, the work of Ozanam. As you explained very clearly, it was the recreation is a genre which was invented in early 17th century. So Ozanam is not the inventor of this genre, and this genre was associated, as you explained, education, the idea of education, with the idea of pleasure. It was very important to make this notion, education related to utility, because of course it was education for young noblemen, for war, for this kind of thing, but also pleasure. And my question is, it's a remark, but it's also a question, what was the part of the pleasure in Ozanam's work? It doesn't seem very important. Of course it exists, but it's relatively tiny if you compare with what was this aspect in early recreation. And also, it's my third remark, in comparison with was recreations in 18th century, because you make a comparison between Ozanam's recreation and the edition by Montucla of Ozanam. But between Ozanam and Montucla, there was 1 century. And during this century, first of all, there were several editions of Ozanams, with additions which would be interesting to watch, because the editors, the publishers had things which could be more related to pleasure, to something more easy, games and things like this. And it's also, in my view, between this period of time in 18th century, if you want to understand the change, you must take in account something you spoke about, but maybe it would be interesting to develop, which is the public. What public? You said it's a thin public, it's a limited public. And I think it's extremely important to insist on that. Recreations, it's a genre which is for amateurs, which were part of the polite society, of the high stratus of the society. It's not, of course, it's completely different from popularization for popular science. And if you consider this, you notice that the genre of creation changed a lot during the 18th century, because during the 18th century, there was a huge development of mathematical education, of course, and the genre of recreation tended to shift in the direction of games, of pleasure. And as you know, I studied the work of Guyot, who published Récréations in 18th century. And in Guyot's Récréations, the part of pleasure, the part of games is much more important than in Ozanam's. So it's my last observation. It's about Montucla. In my view, Montucla's edition is a reaction to this trend. It's a reaction against the success of Guyot's Récréations, which was considered not very serious. And so he took Ozanam, and his project was to make Ozanams more serious, more solid, more with mathematics, which was the mathematics of its time, in opposition of the kind of recreations which was relatively popular among the polite society, which was Guyot's. So it's my. I will conclude about this. I appreciate a lot your presentation. I think it would be still more convincing if you put this more in context, in the social context, in the context of the public. Simply the public, to insist of what kind of public this author, and not only this author, but also the publishers who published these books during the 18th century, what kind of public they wanted to attend to. That's but my question is the proof that your talk was very interesting.
Thank you. Thank you a lot. Monica, may I?
Yeah, absolutely.
Okay.
You have a few minutes to answer back. Yes.
Okay. No, thanks a lot. And these are exactly the points which I am reflecting about in relation to the topic. So the first one about the use of popularization and vulgarization. In Italy too, we use volgarizzazione, with which I am much more comfortable, because vulgarizzazione also allows me a sort of words game with divulgazione, sorry, which allows to me a words game with volgarizzazione. So we have in early modern age the volgarizzazione, which is the translation into Italian vernacular, and then the question will be when volgarizzazione can be considered as a form of divulgazione, and so of dissemination, of an intended dissemination of knowledge, because not all the vernacular works are form of popularization of science, of course. And regarding the many types of math vulgarization or dissemination during the early modern age, I totally agree. We do have many types of récréation, but we also do have many types of works in general about mathematical knowledge to disseminate mathematical knowledge. And the book I was mentioning before, the Mechanicum Liber by Guido del Monte, which was translated in Italian vernacular by Pigafetta, is a perfect example. And that is why I would love to study the communication of math, starting from the 16th century to the end of the 17th century. The other thing you said is very, very well. The publics, okay. The publics is a big problem because we have the intended public, okay. The public as declared also in the frontispiece or in the preface by Ozanam. But my question is, which was the public that really was reached, that really Ozanam's work reached? And of course, we do have different publics at the end of the 17th century, and then with Montucla edition. And this is a point I still need to investigate. And I was particularly thinking at looking through the correspondences, Gazette, and direct or indirect references to the text, and also if I can find something about the copies that were printed, where they were sold, by whom. So these are the aspects I was thinking about, but maybe there are many others I can investigate, and I will be thankful if you can indicate them to me. And the last point, which I think is the most interesting one, and thank you so much, the role of the pleasure and the games and the entertainment. I totally agree. Well, I know your paper on Guyot, and that is why I asked you to chair this seminar, because I know that you have been studying the Récréations by Guyot. And yes, I totally agree that pleasure, the dimension of pleasure and entertainment is not so much present in Ozanam Forces edition, and also in the edition by Montucla, who several times points out that he has modified, amended, and corrected the version of Ozanam in order to update it and to eliminate the errors, the mistakes made by Ozanam. And also there are parts where Montucla explains why the philosophical stone is not a true thing. There is also a part dedicated to the mesmerism, where he explains the scientific knowledge about that and about the capability of magnetism and electricity to cure the body, and he discusses it in a very scientific way. So not like as a tool of entertaining his readers, but just to make the point, to say, okay, the things are like that, he is talking as a member of the Académie des Sciences or of the Commission of the Académie des Sciences. And I think that this is a general aspect of the recreation of the 18th century. So the pleasure, the dimension of entertainment and of the spectacle took much more space, more and more. And this is linked to the addition of the part of physics and physics experiments, electricity, and all that part related to the spectacle of science in the salon. And that is another question, because we usually ask ourselves where do games end and a real communication start. But there's also another question with, I think, like Paola Bertucci or other have addressed, and is where do spectacular science and real science communication begin? Because we cannot a priori consider spectacular science like a form of science communication. We cannot consider it in the past and neither today. So it is a mistake that we are doing both historically but also in the practice of science communication today. So this spectacular dimension absolutely rises the more and the more during the second half of the 18th century. I absolutely agree. Absolutely. Yeah. Thank you a lot.
Okay, so we can now open up the floor for discussion. I think there is a lot of interesting material and a lot of ideas that have come out of this paper and the commentary. So I don't want to kind of reduce the time of anybody else by kind of being the first. So maybe I should wait to see if there is more time. Yeah, there is a problem with the sound, but I could hear it pretty well. So maybe
I just changed my phone line this morning. Now I got a faster one. So.
Well, it's hard to understand at which end the problems are, but I could hear you reasonably well. So I would encourage. So I would ask Karine Kemla. Forgive me for mispronouncing surnames, but Karine, if you could unmute your microphone if you want to ask your question.
Thanks a lot, and thanks a lot for the talk, which was really interesting. I wanted to ask you a question about the way in which you think Ozanam's book was used. Do you think it was used alone or in groups of people? Do you have any hint from the way in which it's written, how you're supposed to learn, how you're supposed to communicate?
That's a wonderful question. Thank you a lot. Sorry, Monica, I just want to greet Professor Singmaster, because I see him and I kind of sent him an email just yesterday. So thank you a lot. Thanks. And so thank you for this wonderful question, because it is an important one, not only for the Récreations Mathématiques by Ozanam, but for the dimension of games in general, because games, mathematical ones, but also scientific theme games, challenge us to understand where they were used and they did circulate, really circulate. So, like, for instance, the mathematical games like these ones by Ozanam were often used also in teaching math. So like with students, so in a sort of collective dimension where there was the teacher and then the students, it may happen that these games, even if they were not originally intended to be as a teaching tools, were used by teachers in their class. Also, what I can imagine is that during the 18th century in France, the salon was the perfect setting for the use of this collection. But also, I can also imagine, and I think that I also read it somewhere, but I cannot remember where, they could be used by individuals who wanted to learn games and puzzles and tricks, and then to propose them in social situations. So the fruition could be also made by the individual in order to learn this type of games and then to propose them. Of course, these are the most intuitive answers that I have, but to discover where and how they were read and yes, and used will ask more time and more and more research to do. And I hope that looking, like for instance, in the correspondences, the private letters or records, historical records, and Gazette, I hope to find some hints about their circulation, but it's not easy at all. Thank you.
Okay, so unless Karine wants to add anything, we'll pass to Cristiano Turbil. If you could unmute your phone, your microphone.
Hello. Ilaria, thank you so much. Terrific paper. I really enjoy it and learn a lot. My question, it's about the aim of this mathematical communication. In particular, I would like to know a little bit about what was the scope and what was the political aim of such communication. Was it addressed just to a specific audience? Was it the aim of creating a new audience? In particular, when I talk about aim, I think about, let's use as an example, the Mechanic Institute created in Great Britain in the early 19th century. The aim of those institutes was to provide the working class with specific learning tool to improve the quality of their work. Can you see anything similar in those, of course, early examples? Thank you.
Thank you, Cristiano, and hi. Thank you a lot. I'm gonna answer to this question only by focusing on Ozanam 4th edition. We are talking about the end of the 17th century. And I'm looking at it in order to answer your question and to the wider panorama of math communication, vulgarization, as you want to call it, in the early modern age. The intention is at the beginning that of giving a dignity to mathematical knowledge, which was a knowledge not cultivated in the universities by itself, I mean. So there was mathematics together with astrology or medicine, but not mathematics, applied mathematics, for instance. They were not taught in a university. So when you look at the first vernacular text about mathematical knowledge, there is the idea of giving a useful knowledge to the ones who may need it, like mechanics or workersman in general. And also there was the aim of spreading a form of knowledge in order to demonstrate that it was a form of real knowledge. So with a long tradition, a classical one, since Greek and the classical authors, and so on. For what concerns the end of the 17th century, and so the Ozanam case, I think that here we have an example of a person really engaged in knowledge dissemination. He has some aspect that records me of Lalande and his love for dissemination of knowledge, considered important by itself. So he was a professor of mathematics, and he conceived the dissemination of knowledge as an important part of his work. So I think that, like he wrote the course de mathématiques, as he said, for military classes and amateurs, so for the people who may need it for practical reasons, and people who may love it just to improve their knowledge. And then probably it may be that the idea came from the editor, or I do not know, actually. I still do not know, maybe I will. He decides to write this collection of games for a much wider public, but the idea is still linked to prove the dignity of mathematics, to prove the utility of mathematics, and to teach in a fun way, in an easy way, mathematics for the pleasure of it. This is what I see in Ozanam. Maybe I'm wrong.
Okay, thank you very much. So I may, because I'm trying to stay an hour and 15 minutes, an hour and a half at maximum. So I may jump in and ask you a question.
Yeah.
First, I would make a comment, though. I think doing an archaeology of reading and looking at the multiple copies. Some multiple copies are surely on Google Books, but I think it's just a matter of going to the libraries, calling out the books, going through. I think it would be interesting to see which parts were read, because it's an enormous amount of words that are collected in these volumes, and very different, as you were saying. There is pyrotechnics, there is pretty much anything that is vaguely related to what we now call mathematics. So I think if you could go through these rather laborious, but I think it would be rewarding path that may give you evidence of use and maybe ownership. Now there are good databases across Europe that try to trace ownership of books as well. And the print run, of course. I mean, I'm sure that there is some dedicated historian of the book in France or somewhere else that wants to dig out. But my question is about innovation, and I have to say I'm totally ignorant of all of this material you have presented, but I was wondering how much innovation there is in Ozanam's text. So there are other mathematical problems that are unknown to the good mathematicians, or is just material that he has collected over time to of medium difficulty to simple, medium, and very difficult for a broad audience, but it's not the kind of mathematics that the mathematicians really do.
Okay, so yeah, thank you. Okay, thank you for your first suggestion. Yes, I surely should do that. It would be really important and enlightening for my research. And so the answers here are two. And The first one is that one of the biggest problem with mathematical recreation is the problem of authorship, because it's pretty impossible to know which problems are new and which problems are old. There is this classification that has made, for instance, Professor Heffer, but also the chronology that has compiled Professor Singmaster, which clearly shows how much all these recreational games basically are the same, maybe change a little bit, but not so much. And it is even difficult to decide if they did change or if they did not. So again, it is a matter of demarcation, a demarcation problem. When we can say that they are changing or not. Then the second answer is that the work is not used by Ozanam, at least to what I know to date, as a tool to widespread his knowledge in mathematics and his authority. Mm-hmm. So it is not like, okay, I use a sort of popular writing, like Galileo. Okay, it is not
Amélie de Châtelet, who writes something for her child, but then it's actually original work.
Yes, yeah. Yes, exactly. It is not like that. Or I mean, I think is not. I still have to write the paper, so I'm able to change my mind. I'm still in time. But the point is also that, and this is another interesting aspect of this text, also outlined by Professor Stingmaster and so on, that they actually reflect the progress and the development of real mathematics. So on the one hand, they remember us how much it not make sense to trace a line between specialist knowledge and popular knowledge, because they are constantly updated depending on the mathematical progress and changes and yes, and I mean mathematical specialist knowledge is conveyed in there. And on the other hand, as I said at the beginning, problems are part of the nature of mathematics itself. So again, it's difficult to decide where real mathematics ends and the games dimension of pure games and the pure amusement begins and starts. But yeah, so these are the answers I have today.
Okay, I think I mean, just for the length of the work and also the complexity, obviously, none of us is well, I'm certainly not a mathematician, and I presume you, so I think it's challenging just to read through the material. So thank you so much. Is there any question? I think there is one last question by Federica Favino. If you want to unmute your microphone. Yes, excellent. There you go.
Ciao. Hello, ciao. Ciao. Thank you, Ilaria. It's really inspiring, this communication. And I'm very glad to know that you are working on this, because I've been thinking for a long time that this is a very important material, especially for the first part of the early modern age, for 16th and 17th century. But I have a question for you. That is, I want to suggest a possible solution for this problem of the absence of algebra in the Récréations by Ozanam. And this is that I was wondering what kind of relationship there is between this publication and the kind of mathematics that Ozanam was teaching at the university.
Mm-hmm.
And this is why the frontispiece of the book reminds me very closely of the handbooks of mathematics for university students. No?
Okay.
For example, at this in this age, at the half of 18th century in Rome, for example, algebra was part of another chair, which was not mathematics, but was Matematica Sublime.
Mm-hmm.
So, and this is why the professor of mathematics was not allowed to teach algebra. Okay.
Okay. Okay.
He could just teach applied mathematics, mathematics useful for practical uses, especially geodesy and something else. This is why they started with arithmetic and geometry, but the algebra was something more theoretical. And for example, in Rome, there was after the reform of Benedict XIV, Thomas Le Sœur. Thomas Le Sœur was teaching especially algebra as a kind of Matematica Sublime, not of mathematics, which was the subject of another teacher. So I want to suggest to look not only to the public of this publication, but also to the institutional setting in a way. And but I think that this can have something to do with what Cristiano, I think, suggested before, and is that probably this was also a way to promote, to self-fashion himself and mathematics with him, which is something very common in all these kind of publications since 17th century. This is what I saw. So these are two things that I want to suggest you to look at.
Thank you, Federica. Thank you a lot. Yes, for the last point, absolutely. Okay, thanks. I will be looking at it. For the first one, my problem is that in the Cours de Mathématiques, he uses the symbolic algebraic notation, but then he dismisses it in the Récréations in favor of the rhetorical form. So the algebraic notion, the algebraic procedures are there, but they are told as it was happening before Descartes' geometry or Viette works or even Bombelli in Italy and all the developments of algebraic notation. So this is why I was more willing to look at it as a choice of language and as a matter of language. But for sure, I will check this point too, and I will also email you for some reference.
Bye.
Thank you.
Okay, I'm just going to check if there are any other questions, but I think we're coming to an end. I wish to thank Ilaria for the stamina that takes to go through a online seminar of this kind, because it's a little bit more challenging, I think, in terms of concentration. At least that's how I've experienced it also with teaching. So I'm very grateful to Ilaria AMPOLLINI and Bruno BELHOSTE for this engaging conversation that you've allowed us to be part of. And if you have any other questions, I'm sure Ilaria is very happy to hear from you, because as we thought about these workshops, these seminars, the idea was to present research in progress, things that young scholars are working on, some in the process of being written up. So getting feedback is absolutely essential for all of us, but particularly for these young colleagues who are trying to get their ideas out. So I do encourage you to write to all of us. And I just wanted to flag up to wrap things up, to flag up the next seminar, which is in 2 weeks' time at 6 p.m. As usual. It's going to be given by Roberto Lalli, Max Planck Institute, Physics, European Integration and the Cold War, the Foundation of the European Physical Society as a Case of Science Diplomacy. The respondent is Simone Turchetti, and the format remains the same. So you can email at the address of the Society, Italian Society for the History of Science. So the email address remains the same if you want to get the Google Meet link for this next seminar. It's a useful way to kind of keep track also of people that are interested in these things. So I wish to thank you all. I wish to thank Maria Conforti for doing the technical support role for this great talk, because she has been gatekeeping and kind of controlling the flux of people coming in, but also recording the talk. And I wish to thank you all for joining us today. Thank you once again.
Thank you so much, and thank you, Professor BELHOSTE. Thank you so much. Thank you.
Thank you very much.
Thank you. Bye.
Bye.
Thank you, everybody.
Thank you.